put together a little presentation basically talking about, how to teach weather, and then I thought I'd expand a little bit and, how to teach kind of the complex topics that we teach besides on the water. So we have a whole bunch of theory topics, and I'm not going to go through them all because you guys all teach different stuff, but the concepts of how do we take something that's really complex and how do we break it down and teach it to people is kind of the goal for tonight. And I'm just going to use weather as a jumping off point. From a generic thing, we'll look at some complex, like how to teach those and some practical ideas around it. And then I thought I'd quickly walk through my weather presentation that I do, so you can steal it for some ideas and that type of thing. I'm not going to do the whole weather presentation because I'm doing it this time next week for the public. So if you're welcome to come out to that, because it'll be a much more in-depth thing. This one's more talking about some of the different slides I've got, why I have them, and it just what works for me. All right, so here comes some relatively fun facts about myself. So my name is David Johnston. I'm here in Toronto, the definite center of Canada. I like to remind people of that. So I've been teaching sea kayaking for 22 years this year, and it's taken me all over Canada, which is pretty great, and parts of the US. What I really enjoy, I like teaching beginner stuff, but I actually really enjoy intermediate and advanced courses. But my real passion is teaching instructors. So like how to teach, how to work with people to get the most out of people. That's what I actually really enjoy most. So that's my relatively fun fact number one. Another fun fact, 2006, I was a background character in Corner Gas once, won a contest. And my other final fun fact is I accidentally marched in a pro-communist parade on Red Square in Russia. And one of those is a lie. Let's move on. All right. So the instructor part is the lie. So just kind of some random stuff before we really get started with this is, you guys all come from different experience, and we've got whitewater kayak instructors and sea kayak and canoe instructors here. And it's all about I'm trying to be as middle of the road as I can to help you out, but you've got your own experience and your own background. So some of the stuff will work for you. Not all of it will, but let's get started. So here's our first. So how do you figure out what to teach? The manual just says teach navigation or teach weather. So the first thing I put it through is the 4-step filter. So what's the level of expertise? So beginner versus intermediate versus an advanced course. That's pretty straightforward. And you're going to try to teach obviously to their level that they're coming in on. Number 2, so what's the environment? And this is a really good way, especially for weather and navigation, that the depth of stuff you can teach is really, really deep. So what are they going out in, and what level of knowledge do they need to go out in that environment that the manual says they can go out in this much sea or out of the harbor or out for expeditions? So what do they need? And that's a really good way to kind of say, well, we can scale back this lesson because they're going to be out only puttering around the harbor or the bay, for example. So that's one of the other tips is I kind of put through that filter, and that's been super helpful for me, especially in the early days. So then the other one here, so when you're looking through your stuff and you're filtering it out, so is the information you want to give them, is it critical or nice to know? And start cutting out the nice to know stuff. Stick with the critical, and that's probably going to fill, which is my last one, is how much time do you have? So you've got 10 minutes or 20 minutes or 2 hours to teach whatever topic it is, and you're automatically going to probably have way too much information. So cutting back the nice to know information that you could give them later. So this helped me for sure in getting this thing going. All right, so let's look at some of the things that I teach in particular in the weather, and then we're going to move into some more kind of how to frame just general topics. So what I do for it is, in weather in particular, the beginner level, and this is where we have all different environments, and what you end up teaching or talking about to your students changes significantly, obviously depend on the time. So for me, is at a beginner level, he probably have like 15 minutes sitting around the table over lunch or something like that. And I really try to put weather in the context of risk assessment and mitigation. So they don't need to know any of the science at this level, but they definitely need to know, you know, when should I get off the water, or, you know, like that type of thing. So the angle about weather at a really junior level is it's all about risk assessment. I really try to instill the idea of weather observation throughout the day. So it's, you know, weather is all about what was it like this morning compared to what it is now. Is it deteriorating or getting better? And maybe we should change our plan. So a lot of people don't think in this context, but it's all about looking up whenever you get a chance to see what's going on up there. And then some of the real practical stuff at the very early stages. So where do I get a weather forecast? If you're in, say, the Great Lakes or the ocean environment, you might talk the difference between a land and a marine forecast. That's not available everywhere, but if you are, give them that information. So if you're in an area like here in Ontario, lightning obviously is a big deal for us. So we talk about lightning all the time. And then the last part is signs of an imminent weather change. So you see that there is a sweet little 15-minute lesson, gives people all the safety they need. They got the fear of God in them about lightning safety, and they are ready to go. 15 minutes and you're done, and it's not a lot of science, which is exactly because they're to go paddling. At intermediate level, things change a little bit, and you got a lot more things to play with, and you lessons, depending on what you're doing, could be 20 minutes, could be up to an hour. If you're on a multi-day course, then you can spread that kind of hour of teaching up over things. And so I tend to get into a little bit more science because I love the science of teaching it, and I've kind of figured out how to explain it. So I get into more complex things like high and low pressure systems, warm fronts, cold fronts, because people are going out on multi-day trips at this point. And so they kind of want to know this level of information, and they're committed to paddling, so they want to know more about the different things that are available for them. I get into things like short-term weather forecasting at this stage. So you're out for 3 or 4 days, or let's say you're out for a long weekend trip. You don't have access to weather on the internet. So what's ahead of you for the afternoon? So we talk about cloud types and things like that. And then at an intermediate level, I like talking about wind effects on shoreline and kind of how that plays out, definitely in a marine environment. And so then you got time for homework. So I put together a little weather forecasting activity, which could be as simple as get a forecast for tomorrow. That's your homework tomorrow. So what is it in the morning, and how did it play out over the day? So people kind of got to go find the information, then they got to compare what the computer said to what actually happened in real life. So there's some stuff you can tease out of it at that stage. Yeah, it's a fun activity. And, you know, so I try to break it up if I can over into a couple little chunks, because it can be pretty dry for some people. So, and then my last one, at the advanced level, you know, we're talking multi-day courses. So we tend to get into much more information around global weather information. So trade winds, jet streams, super nerdy stuff like Hadley cells and those types of things. We get into other weird things like wind and its effect over water. So wave development and wave theory. And, oh, I love it, and the students hate it, but I don't really care. So those are kind of the little kind of a high level breakdown of what I end up covering. So Dan's got a question. So would you place your intermediate or advanced for level 2 course? Oh, very nice. Thank you. So where what I teach depends on a couple things. So how much time do I have? What level of interest do the students have in this? But it really comes back to how much time I've got. So this is kind of a standard I end up doing. So if it's a short, like a beginner weekend course somewhere, I'm not going to get into high and low pressure systems, but if you're on a 4 or 5 day course, you got lots of time to talk about cool stuff like that, because you're going to see it going by overhead. So it's a good chance to chat about it. Did that work, Dan? Charles got a question. So so how much would you recommend that we as instructors make sure we know the nice to know? I'm going to come back to it. So Charles, if I don't answer, definitely let me know. Okay. All right. So when we're talking about theory topics in general, there's really kind of 3 little classic ways that you could teach or present the information. And people could split hairs in other ones, but I only had room for 3. So you could do a classroom discussion or a group discussion around something. You could do games, or you could do a lecture style, kind of like what I'm doing right now. So class or group discussion, they are wonderful, but they have their pros and cons for sure. So this would be more like you're leading a discussion with the group, teasing the information out of them for it. It's really highly interactive. The best part is you don't do all the talking, which is nice. You can get your students talking about stuff, especially if they know a little bit about the subject already. They love talking about it, but that's its Achilles heel, and that often they don't know that what they're saying is right or wrong. So I've had times where somebody's a super keener about something, and I've realized partway through it that, you know, she knew nothing about it and it was confusing everybody. So you kind of got to figure out how to navigate through that. It's risky giving the lesson over to your students, but it's a nice way to break it up. And then the other one is with group discussions is sometimes if they don't go quite as well, students kind of grumble because, you know, they're there to hear you talk. So you kind of got to give a blend between different ways to do it. So if you're constantly doing a group interaction, somebody's going to call you on that. So that's a kind of group or discussion. Let's chat quick about games. So games are awesome, and it's a really nice blend between all these things to do some games if that's your thing. So they're really interactive. They're obviously fun and keep people moving. There's lots of people who hate games, and this kid is one of them. I hate games, so it's just not my thing at all. I don't really like it, but that's just me. My therapist and I were working our way through it. Okay. The one thing to kind of keep in mind around games is while they work great in kind of breaking up the monotony of a really dry lesson, sometimes they don't work for really complex concepts. So don't try to use them to teach really complex things. And you got to really figure out your time between time and the value of learning. So that return on the investment. So if it takes 20 minutes to play a game that you could explain it to them in 3 minutes, it's not really worth it. So you just kind of got to think that through. Okay. And the last one, so lecture style, it's got some really good advantages. You know, you get to control the narrative, the pace, and the time. And sometimes it's just the best way to hammer through a lot of material in a really efficient way. So it sometimes works. It doesn't work for everything. And you kind of want to break it up. But things like this is a good topic. You really don't want to do this any other way. The problem with it is that if you or your material is boring, you lose your audience pretty fast. So you just got to pay attention a little bit to that. All right, any questions so far? Just, African swallows, you guys.
No, skip down to Charles. He had a question.
Oh, yeah, activities. Yeah. So I'm going to come back to that too. I've got a piece on it as well. Okay. So thinking about just some general concepts around teaching complex subjects. This is all about these are just 4 key ways that you can teach almost anything with this. And when you start to look at them, you're like, that seems, it's not rocket surgery. It's pretty straightforward. So obviously the first one is simplify it as much as you can. So break it down into small little tiny baby steps and little tiny chunks. And then the other key thing is you've got to put those little tiny pieces in order so that you can explain them in little pieces and that they build on each other from the concept before. It's like climbing a set of stairs. It's a lot more work to double stair it up or 3 stairs at a time, but little baby steps all the way up, and you'll eventually get to the top. So what I end up doing, so something that's complex, like if you had to teach, what is a low pressure system? So, what is it? You might want to talk about how they form. Okay, well, but they want to know how it affects them and what do they look like. So you kind of got to think of put it in a right order that you can explain it. So I really kind of break it down into little tiny steps, figure out what's the order that they have to go in, and then that helps quite a little bit. And so simplify it for sure. So the other one is repeat, and this is another great little teacher's trick for it. So repeat your information, the critical pieces of your information, as many times as you can, and you want to hook them into different parts of the lesson itself. So or come back to that piece as many times as you can. Because if you've got 5 points and 2 of them are your key piece of information, you kind of want to stitch it together so it makes sense, and then come back to the 2 key points so they walk away knowing that piece. Okay. And then graphics and phrases are nice little tricks to kind of put that back together again. So, and we'll talk a little bit about PowerPoint presentations in a second. So connect, this is another one. So the idea around it is connecting the new thing with something they already know or already have experienced. So if you can build that bridge between it, they'll be able to draw from that experience or that knowledge and be able to pick it up a lot quicker. So there's some ways that we could do that. Stories, metaphors, and shared group experiences is particularly powerful. So the more that you can relate something back to their life or something back to real life, like back in the city, or that kind of concept. So the quote below, so this is based on, remember something happened this morning. So the big storm came in. Do you remember what the clouds looked like? Okay, let's talk about kind of what happened, or, you know, it's kind of an idea. So if you can hook back to that. Navigation's a good example. I found, so people get terrified to navigate in the forest or out in the wilderness. They think it's really complex, and they, you know, it's really intimidating for everybody. So what I realized was that navigation on a lake or in the forest is generally the same thing as if they were navigating over to the grocery store. The concepts are the exact type of thing. They're still following, they're following a path. They're thinking about, where do I go? Where do I turn? There's points to tell them that they've gone too far, all those types of things. So I found that navigation, in my particular case, my effectiveness went way up as soon as I said, it's really no different. Let's go back to how you already got here. What are some ways that you navigated to this location? And so hooking that back, people are like, okay, you can bridge across. So connecting it to what they already know or experience is a key, super successful thing. And my 4th point around this is, so you're going to apply it. So is the same when you were in school, teacher, blah, 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 taught you the stuff. And now let's figure out what you need to do. So there's things like, you've got options, you got homeworks and tests, you got little group projects, whatever creative way you want to try to drill that home is super effective. And it all depends on your time, obviously your interest, the group's interest, and what you're trying to accommodate for that. But you've got things like, so the idea of saying, so tonight, go find a forecast, or tomorrow morning before you get here, we're going to talk about the forecast, and then we're going to compare it later in the day of how accurate it was. It's a really fast little activity that doesn't take much to set up, but there's a lot of learning in it. So being able to apply it is really key, okay? So those are my 4 pieces. So just backing up. So simplify it, put it in a really good order as best you can, repeating it and going back to review, like this, we're doing it right now. So repeating the kind of key pieces, connecting it to some type of memory or experience they've already got, and which I always felt was the biggest problem with calculus. And like, how do you bring that into real life? Calculus did a terrible job in trying to market itself. So, and the last one is apply it, turn it into something in real life. Any questions so far? I'm looking at the chat board over here. All right, let's move on. So I got a couple random teaching tips, and this is based on, now Mike Gilbert's lost over calculus. Let's move on. Let's ignore that. So I taught a lot, and I've made a lot of mistakes over the years, and pretty much everything out of here is stuff that I've gone wrong, and tried to learn from it, and hopefully it's a little bit better. But some random teaching tips that'll help you guys out. So you're teaching your first thing. This is my first one. So only talk about what you know, and everybody will think you're super smart. Keep an eye out for that one super keen or tricky student who kind of already has a bit of knowledge and will either try to trip you up or ask really in-depth questions. So yeah, stick your lesson plan really tight, only cover the things that you know well, and go with that. If a student asks a question that you don't really know the answer to, don't go in that room, because all of a sudden you're like fumbling, stumbling your way through. So your goal is to like pull the wool over your eyes and make them think that you're super duper smart. So stick to what you know. And if that there's nothing wrong with saying you don't know. Absolutely nothing wrong with it. So students will respect you for it, and there's nothing wrong with piping up and say, I'll just find out for you and figure out for the next day, or email them later in the week, that type of thing. So if you don't know and you start fumbling your way through, or if you kind of know but don't really know, so you take a chance at it and then you stumble up and it's even worse, it's way more embarrassing. So people will respect you for it. Less is often more. Keep that in mind with both lessons and everything. And then my last one is for this is they're not expecting you to be a meteorologist. Like, so them themselves are not expecting to become meteorologists at the end of it. Same with navigation. They're not expecting to be super experts. So you don't need to give them everything. You just want to give them enough for what they need to know. Okay, so don't stress about that type of thing. Number 5, so teach to the group and not to that one keener. You've all seen it before where you're teaching a class, or especially if you're watching someone else teach. They're teaching to the class and there's one person with her hand up every time and she's got lots of questions and she's loving that seminar and you're loving it, but forgetting the fact that everybody else is bored out of their mind and you've kind of lost 9 people, but you've got one super keener. So just be really careful that you don't use that one super keener as the litmus test for everyone else. So watch that you don't bore everybody, and we all fall in that trap. So just be careful with it. And then my last little point is don't stress. They already think you're an expert, and your goal is just to keep them thinking that you're an expert. And as long as you do that, you're definitely going to be successful. Okay, so this is, for brand new instructors or instructors who are kind of moving into teaching new things they haven't taught before, or new areas or deeper topics. They think you're an expert, so that's your goal. It's just kind of continue thinking them are, and you're going to be fine. So. All right, let's get practical. So there's a bunch of stuff out there. And so this is just kind of getting into what we can build and where we can find stuff. So I found that for finding stuff, there's a ton of resources obviously out on the internet. Aim towards looking for resources that are aimed towards primary school teachers, Girl Guides, and Scout leaders, because that's right the perfect sweet spot for the type of depth of knowledge that we need. So you could find 1,000 lesson plans on how to use a compass for Scout leaders, and those are perfect. It's a great thing. If you find that same lesson plan but written towards a high school or university professor, you're just going to bore everybody to death. It's going to be 800 pages long. Don't bother with it. So yeah, there's lots of teaching resources out there that's free, and you just punch in the audience you're looking for, like compass lesson plan or navigation lesson plan primary teachers, gets you tons of stuff. So that's I found what works for me. Just sometimes it's obviously way too simple, but there's lots of great graphics in those types of things that you can steal and you can go from there. So yeah, Cadets, definitely. Cadets is another great resource for lots of things. Online, so Google Books has got lots of resources. So they've scanned billions of books. You won't find the entire books, and you'll find lots of chapters that are cut out of it. But if you're searching for it, you can find some interesting topics, especially if you're looking for some history or older books, you get access through that. And of course, the one section that you really need isn't part of it, but it's a. All right, and moving on. So Google Books is another really good resources. Amazon, their book department has a lot of books scanned in, at least kind of some initial stuff. So you can start from there. And then local libraries it's got everything under the sun. So if you're looking for resources, there's tons of stuff obviously online, but books is the best way to go when you're looking for more in-depth knowledge. Okay. So PowerPoint presentations. They're super effective for a bunch of things. I'm a big advocate for it. A bunch of years ago, I was like, I don't really need them. I'm teaching on the water and I'm teaching stuff. And then I realized it's got benefits beyond just using it as a presentation. So it gives you stuff for your students to look at and makes it a whole lot more interesting than just dry, boring lesson on how to teach lessons. So it makes something super dry a little bit, it's like gravy on white turkey. You know, it's pretty dry, boring meat, but the gravy is the best part about it. So it gives them something good to look at, but the best advantage is that it forces you to come up with really good material, and it forces you to really think through, how do I present this information and what order do I need to present it in, because it's in slides. So 1, 2, 3, 4, 5, what's the best way to do that? So I found that it was really helpful for me, especially thinking through the words on the screen. It forced me, as someone who loves to talk a lot, to really get really tight with how to explain things. So even if you don't use the presentations, it's a good way to wrap complex topics around your head. So, but then because the lesson is laid out in front of you, the PowerPoint presentation does the work in keeping you on topic and on time. So it's really beneficial, especially if you got students who ask questions that you could come back to later, because you know I've got a slide on that topic, or I don't know what to say next because I'm kind of fuddled up in my lesson. You just click next on the arrow. So PowerPoints are really definitely beneficial. So what I then discovered is I don't bring a computer out all the time, and I'm somewhere without internet, and I'm somewhere where on the water. So print out that presentation. You can get those plastic sleeves and throw it in a plastic binder, and you can just bring it out on the water, and you can keep it in the waterproof bag, and students love it. They definitely love it. Even if you just use the printed version or an actual computer version, it's wonderful. So in my head, it made my teaching significantly more effective as soon as I started to do it. So you can laminate it. The only problem why I'm not a big fan of laminating myself is just, as soon as it's laminated, you can't change that topic again. And so I'm kind of fiddling around and massaging my material all the time. So I just have it in a little plastic insert, and it seems to work great. But you can do whatever you want, you're adults. Okay. Animations. So I've got a couple animations for teaching weather, and obviously you're going to need a computer for that, but you can find lots of animations out there, and there's a lot of YouTube to GIF converters. So you can, if you find a piece of an animation out of a video, you can convert it over. The Google, it'll show you where to go for that, and that's super effective. I'll show you a couple that I've got that work great. Video. So video's a bit of a double-edged sword, and oh, I'm really distracted by that duck. Hold on. So this duck, we're out paddling one day, and we're sitting around gossiping and eating, and all of a sudden this duck just hopped on up, and it's pretty awesome. Stood up there for about 5 minutes, stared at us. I thought it was going to go for our throat, but it didn't. But yeah, so anyways, that's the goat. No, it's not a goat. Sorry, that's the duck. So yeah, so video is really good because it's really obviously can take something that's really complex and can show them, show complex things. The problem with video is that they're either garbage, they're either really too long, or inaccurate. So I find that there's some really good videos to how to explain things like how to find latitude and longitude on a map, for example. It's a 20-minute video, but there's 4 minutes of really good information in there. So if you can set your stuff up so that it only shows that little bit, then you can do it. There's a lot of YouTube downloader websites as well that you can download the particular piece you're looking for if you need it for offline. You could just, if you're somewhere without internet, for example. So yeah, so don't, video is good, just be really careful with it, but it can be a super powerful tool when you find the gem that you can use. Video is also really good if you're teaching an intermediate course, let's say, or a course where you have some homework that you want them to prep before showing up. So if you've got a lot of stuff that you need to teach in a short amount of time, you can get them learning it themselves. So I'll throw one out that I teach. Tides and currents is a good example. There are so many good resources out there and good videos out there that I could send you, like, watch this, watch this, watch this, answer these questions, and 80% of my tide lesson gets taught before they show up. So you can kind of front load your lessons if you've got a lot of material. Why not? They can watch that stuff at home and not have to sit and listen to you explain it at 8 o'clock at night with lots of bugs flying around. So, so it's really good. Oh yeah, Brian, he said he uses videos. He often sends videos after the fact. So that's a follow-up piece. So that's a nice little piece as well. So yeah, so you got lots of stuff to work with. I found that I have presentations for almost every theory topic that I have now, and I don't use them for every single one, but it's really helped me streamline a lot of my theory presentations. Plus I can mix and match depending on how much time or what my audience really needs for that. So, yeah, any questions about that so far? And then we'll go take a look at my presentation. Okay. I like this chat thing. It's actually, a lot of people are on it. At work, it's just silence all the time. Okay, so let's take a look at my weather piece before we get started. So just keep in mind, everybody does every topic completely different. And this is just one, as I said, one super nerd's method that works for me. In my case, I'm very comfortable getting super technical with students, beginners or advanced, just because I've kind of been able to, I'm super nerdy about that stuff, so I'm comfortable with it. Just the way that I do it doesn't mean that you have to go your own way. It's just kind of throwing out a bunch of ideas. In this particular case, in my kind of master presentation that I've got around weather is 60 slides of stuff that gets tailored to whatever the students need. So I just skip over slides if it's a beginner or intermediate, or it's 15 minutes or 2 hours. So I built kind of every conceivable type of topic, and I might not show a particular slide to people, but they might have a question. I'd be like, let's go to slide 42, and I'll show you that piece. So this is kind of worked out a bit for me, and we're definitely not going to go through every slide tonight. So we're just going to hit the high points of some of the ones. So let's skip over to weather. This guy came out of a weather presentation probably about 10 years ago that I saw somebody give at a symposium. And, there's those watershed moments that your mind is blown by it. And this was the presentation for me. And he was a guy who taught really high-end racers for sailing in a particular offshore weather. That was his expertise. And so amateur meteorologist type thing. And that was, so he came and he did a presentation. He tailored to kind of what paddlers need. And man, it blew me away because there was so much science, but at no point did you think you were learning it. So it really changed my whole direction of how I present a lot of information. So, and I've since modified it quite a bit from there, but we'll hit some of the high points for it. I always start with my Surgeon General's warning at the beginning that they will, at the end of this, they will definitely not become either of these two people. So it kind of, in my humorous way, to kind of downplay it a little, set some expectations a little bit. So as I remind people that they actually went to school to become a meteorologist. And in my navigation one, I have a very similar one, but people actually went to school to become a pirate. So I start with this type of warning. And then I frame weather because there's so much material. And I'm going to talk to you guys as kind of a more upper intermediate level of what I cover, as opposed to like this very beginner, but we'll kind of cover those. So as paddlers, so what are we interested in? So we're interested in these 4 key pieces. So, and this is, so wind direction, where it's coming from, air or water temperature, wave height is a big thing, especially in the marine environment where that's an issue, and whether it's going to rain or not. When it really comes down to it, those are what we're paying attention to. Okay. Then it took me a long time to kind of struggle on how to organize my lesson. And when you're teaching that you have a lot of material, you need to kind of come up with a framework. And I found this actually worked well for me. So we have weather, there's 3 kind of chunks of weather. There's weather that affects things globally or continent-wide. There's other stuff that happens regionally, so as big as a province or a state, or just a small section of it. And then there's things that affect you at this end of the lake. So really small local weather. And there are 3 distinct different types of things, and they affect us in different ways. So I found it's a nice way to kind of organize it if you're presenting lots of information. If it's a beginner, then I'm only focusing on the very bottom end. So local weather, what do they need? We'll talk about that in a second. But so if we have more time and an interested party, then I'll start at globally and work our way down regionally to local. So what causes weather? This is always my opening question. So where does weather come from? And weather comes mainly from the Mr. Sun, and that's the key biggest piece that drives the engine here. So it gets sun's radiation comes through, hits the Earth, and because the Earth is a globe, and because it's got big land mass and water mass, you've got what's called differential heating. So it doesn't heat up at the exact same time. Half the Earth is in the shadow and half it's facing in, and plus there's stuff at the pole. So you've got big chunks of cold air and hot air, and this is all trying to constantly move around and try to settle itself out. But because it's not flat and it's spinning, you get this what's called differential heating. And so this causes a significant number of air currents traveling around. This is my more advanced section, but I'll hit through kind of a real high points on this. And I think this is really beneficial to people because they kind of get a sense of, kind of what's happening in the high level. So I explain here, let's just turn on my little pointer. So we know because of differential heating, we have there's areas with hot air and air with cooler air. And we know that when air gets hot, what happens to it? It rises. So if we look at the equator, where in theory it's the hottest point of the Earth, but obviously not, you have all this vertical lift up here, and it's got all this moisture, and it rises. And when it cools, it condenses, turns into rain, and comes back down, which is one of the reasons why kind of typically the equator is where, if there's a lot of rainforest, tends to be in that zone, right, kind of in the equatorial zone. Okay, and that's because what happens is all this hot air that rises, goes to the top of the troposphere, starts to cool down, loses all its moisture, and either flows north or flows south. Okay, so it travels across, it cools down, and when air cools down, what happens to it? It gets dense and it falls, and it comes back down, and it either will go back towards the equator, complete a cycle all the way around, or it'll go towards the north, where at around 60 degrees, it picks up, it gets warm enough, and the same thing happens up here. So you've got these two sections of a lot of rising air, and it condenses, and so you get this band where you get a lot of water right flowing below it, both at the equator and at kind of around the 60-degree mark, which is one of the reasons why, like our area here, like in Canada, we tend to get a lot more moisture. We don't get the same amount of type of deserts as you get farther south in California, because the air has come down and it's really dry, blowing across the plains. It doesn't have a lot of moisture in it. Now, there's way more science in that than this. This is obviously the 2-minute version of it, and people, like I said, go to school for this, is way more into it, but this is kind of a really high level thing. And it kind of gives people a sense of what's going on. You could start to dip into things that this air that rises up and spins out on either side is where the polar jet stream is. So you could talk a little bit about jet stream if you're interested in that. The other interesting thing about it is you've got another polar cell way up at the top here, and it's spinning around. So you've got cold air that's coming down, and it blows off the poles and comes down, and is exactly what happens in the wintertime when you get cold air coming off the north. And so that's this dry air coming blowing across the land here, warms up, picks up some moisture, goes back up and condenses and turns into snow or rain. So you got a bunch of stuff that's happening out there. And this all has to do with differential heating and air moving around. So how does this play out for us as paddlers, these different cells? What we get is the trade winds out of it. So you have different air cells that are spinning and rotating around, but because the Earth is spinning underneath you, or underneath the air masses, air tends to blow off in a kind of a set specific direction. So which is why for us down south here, most of the trade winds come from the southwest. In different parts, it's slightly different, but generally speaking, a lot of weather comes from the southwest, and that's exactly what's happening to those big air masses above us. Okay. So so and then from that's as much detail as I really like getting into with most people, because after that, man, like they're as bored as you currently are right now. It's a lot of information to figure out. But when you have the time, I enjoy it. I think it's good information for people to have at a really high level of what's happening above them before I start moving down into more regional weather. Is there any questions around that section so far? I'll keep an eye on it, and we can ask so type it in there if you have it. So regional weather, we start to change, and we now start to talk about things that happen obviously at a regional level. So maybe as big as the state systems or as big as the province, and we go from there. So my first big jumping off point is high and low pressure systems. There's a lot of really cool there's a lot of really cool stuff. And it took me a long time to figure out how can I explain this concept to people really simply. And I stumbled upon this graphic with the little arrows, and it's got everything I need to explain what's going on here. So, and I threw it on top of a map so that people have a context to how big these things are. You know, so they could be several states big, or they could be really small, but generally they're, you know, multiple states or half a state or states, provinces big. So, so I explain high and low pressure systems as there's different types of air that has similar density, similar temperature. They tend to like to hang out with each other. So warm, moist air tends to like to hang out with its own friends, and cool, dry air likes to hang out together. And you get these high and low pressure systems, how they form, and that you can't, you know, I never really get into that because there's so much science behind it. But but what happens is this is what affects us, and this is what pushes weather through to people. So we got high pressure systems, and you can see what they tends to bring when those big air masses over you brings what? It's cool, sunny, wonderful weather out there. So that's kind of your typical nice, always sunny on Mondays, never sunny on weekend type weather. So high pressure systems move into your area. Low pressure systems are the opposite, and that's where the storms are found. So warm, moist, rainy weather, cloudy, often high winds. That's a typical low pressure system. Out of this, you can see there's the arrows that go in a certain way, and that just has to do with the way that wind blows off of them. And so they rotate around, and a high pressure system rotates clockwise, and a low pressure rotates counterclockwise. And so it's really easy for people to pick up on how this whole thing works. And the other part that I really like about this is that we got a high pressure and low pressure, and it's feeding into one another, and you can kind of tease that out as well. So there's some really cool stuff around this. You could get into talking about how if you're in a certain part, if the low is either north of you or south or east or west, you got wind blowing in predictable ways. There's lots of really cool stuff you can tease out of this. And I found this graphic and I stole it as fast as I could. So this is another graphic that it took me a while to kind of come up with, and is just this idea of, so if we talk about, I talk a little bit about high pressure systems, but really low pressure systems where the action is. So if we focus within low pressure systems, there's some things that you guys have probably talked about, you know, high and low, warm front and cold fronts. So if we look inside of a spinning low pressure system, it's essentially, it's spinning counterclockwise. And what it does is it pulls up, on one side, it pulls up a lot of warm, moist air from the south. And on the other side, it's pulling in a lot of cold, dry air from the north. That's essentially what that ends up doing. And they spin around and they kind of mix themselves up, kind of like a, you know, a swirly. So the key thing that what they talk about is that we start to, the other concept that I would get to people is what's called a front. And a front is essentially is just the boundary between air masses. So we got one here, we got another one up here. At the very top, we have some air that's hanging out at the top. Another air mass is getting drawn down across Michigan, and something's coming up from the deep south, getting pulled up into southern Ontario. So generally, if you're in one side, like one of those three bubbles, your air is probably fairly stable because not a lot is happening. But as soon as a new air mass moves into your area, that boundary between that, which is called the front, but it doesn't matter. You don't need to know the name. It doesn't really matter at all. The concept's the important part. So when the boundary happens, that's where exciting weather happens, okay? There's two different types. Let's take a look at this. We're gonna come back to this graphic in a sec. So this little animation talks about what's called a warm front. And essentially, you've got cool air sitting over you, and you got warm air that's moving into you. So if we go back to our graphic, if you were up here, up in North Bay, you've got cool air already. The low pressure system has moved in, and it's pulling in warm air into your area, and it's called a warm front. So you've got your little tent that's down here, and over a span of probably anywhere from 12 to 36 hours, this slow moving system starts to move into your area. And if you look up, as the air mass starts to go over your tent, you can see it's all little tiny wispy clouds, and then lower, thicker clouds, and then even lower, thicker clouds as the warm front starts to move in. And as eventually the clouds get lower, it starts to rain, and you get wet. It's a warm front. Lasts for 24 hours, 36 hours, and then it moves on out of there. They tend to move really slow because it's hot, lazy, tired air. Okay. So when you see those clouds starting to group together and lower, you know a warm front is moving into your area, and you don't really need to be super worried because it generally associates with not really drastic storms. There's always the exception, but generally it's going to rain and it moves out. It's not a big deal. It's what's called the cold front is the one that we need to worry about. And this is what I explain to people. This is a good key information. So when cooler air is moving into your area, and you guys have seen this animation before, your little tent, all of a sudden cold air comes flying through in the middle of the afternoon, and a huge big storm erupts super fast. Look at that, cold air goes in. Because it's cold and dense, it shoves all that warm air up into the atmosphere where it gets cool and condenses and gets a big giant storm. So we get a lot of rising air, got clouds forming super fast. We got molecules banging against each other because of the high winds. And what's that going to create? It's going to create lightning. So these are the types of storms that are associated with a lot of rain, a lot of wind, a lot of lightning, and you definitely don't want to be out in these types of things. Okay. So yeah, so it happens basically on the line whenever you've got warm air already and cool air is moving into your area. You should expect something exciting like that to happen. And so that's my kind of quick and dirty version of how to explain warm and cold fronts. And I found that this graphic actually worked out really well because I can tease locations that my audience knows and weather we tend to get a lot. So Toronto tends to really get these hot, hazy days in the summer. A big storm comes flying through and it gets cold on the other side. What happened? A cold front came through. So there's a lot of stuff that I can hook back into real life. At the local level, and this is the section that I actually really enjoy because it's kind of the really practical, dirty stuff. So what's happening right in front of us? And we want to start to get into making some observations, and clouds are your best thing. So I talk a little bit about clouds. Clouds can be super confusing for people because there's a million different shapes and heights and all kinds of weird things that happen. So don't get hung up in those details. The names don't matter. The concepts are the important part for this whole thing. So we've got 3 different types of clouds you could talk about. If you want to give the names, you can, but I tell people it doesn't matter. It's there to try to impress people. So we've got wispy clouds, like the cirrus clouds that look like hair or that type of stuff way up and high. We've got cumulus, which means heap or pile. And then the other one is stratus, which is layered clouds. So there's kind of, when you really break it down, there's just 3 different types. And then the other concept that I get across to people is that within, we got 3 different types, but we have kind of 3 different zones of atmosphere. And you have stuff that happens in the upper level, stuff that happens in the mid-level, stuff that happens at the lower level. Generally speaking, the type of clouds that are at the high level, ignoring the big giant cumulative nimbus clouds. So the high level stuff, that is a precursor to something happening, but in a couple days or tomorrow. Today, it's going to be great. Mid-level clouds, keep an eye on them. Low-level clouds, you definitely want to pay attention to them. So it's kind of a simple way to kind of make things really practical. You could give a couple examples. So high-level clouds. So you got the wispy ones that people have seen. And if you're sitting outside, you can point to them throughout the day or that type of thing. So what does this mean? You know, a change in the weather is likely going to happen in the next 24 hours, probably. Look for the temperature to get probably a bit warmer, clouds and rains. So cirrus clouds tend to be a precursor to a warm front moving in. At the mid-level stuff, you start to now get the clumpy clouds. You got birds flying by, but it indicates the air above us is starting to get unstable, especially if you notice that yesterday was clear. Now it's starting to get coming together and lowering. It's all about trends. So now the weather changes probably 12 to 18 hours away. So probably, mid-morning tomorrow, like that type of thing. So, and then the low-level stuff is you got a bunch of different things. So the change has already happened. You already know it because you looked outside and it's either raining, it's foggy, or it's about to. And it's, really intuitive, but the low-level stuff. So the trend of weather changing is about high-level wispy, so clouds coming together and lowering. And there's way more science, but that's what they need to know. So you can really simplify it down to stuff that they get right away. And then the final one is I talk about, obviously, cumulonimbus clouds in particular, the big, giant, scary ones, because it's the thing that practically affects you as a paddler going out. So I spent a little bit of time just chatting about that, chatting about how the system works. They blow up, lots of stuff happens, and it dissipates. I found this really great little video. Let's play this guy. Look at this thing. This little time lapse. It's only 45 seconds long, and you can watch this bad boy blow up. Whoa, look at this thing go. It's textbook. It's so good. Look what's happening across the top. You start to get this anvil shape where it starts to stretch out. It's hit the top of the troposphere, and it's now blending out. There's a lot of really cool stuff happening, but you look right over here. Look at this guy. It's still building up here, but it's not building up over here. It's all dissipating. So there's a lot of, you can watch this guy, and I built, I captioned it over to an animation for if I'm doing somewhere where there's no internet. So this is really cool because, you know, once I've seen it like 18,000 times. There's a lot of really neat things that's happening here. And this is just a short little one. It's only 5 or 6 seconds, so I can repeat it over a bunch of times so that people can see it. So I actually like using the animation better than the actual video. So let's watch it one more time because it's super cool. So this is probably in the span. This is a nice piece you can talk about how this probably has gone from 0 to 100 miles an hour inside of probably about 6 or 7 minutes. That's probably been sped up to about that speed. So it looks like a volcano explosion. So, and then getting close to the end here. Okay, so I leave them almost certainly beginners with the signs of an imminent weather change. So how do you know something's going to happen? And it's pretty simple. So the first one is wind, and you know if the weather is going to change for the bad when wind increases in speed and changes direction. And in particular, because you guys are a little bit more advanced, is if it changes direction in a counterclockwise rotation. So if the wind was blowing, you're paddling or you're camping and the wind was coming out of the north, but now it's coming out of the west, it's changed in a counterclockwise rotation, which generally means deteriorating weather. But the key thing is just knowing that increase in speed and change in direction. So it was blowing off one cheek, now it's blowing off the other. Something's happened. You need to get your spidey sense. So that's the first one for sure if it's blowing up. Other one is temperature. Way harder to measure because it's really subtle, but the temperature just before a big storm will increase for it. This is hard because you need some type of instrument. You can't just tell. Okay? And then the other one you can't tell is obviously air pressure. So if you had a barometer with you, you could tell. If you had an old man with bad knees, you could tell. You know, that type of thing. But it's another sign that when the pressure drops when a low pressure system starts to move in your area, and you tend to get storms for it. So that's the low pressure. And then the other final one is clouds. So bunching together and lowering. For two of these, you need some type of sensor, so temperature and air pressure. The other two, you just need eyes. And that's what makes them really good. So if you focused on anything, it's as soon as the wind comes up, as soon as you start to notice the clouds, which is why it's important to pay attention to it as the day goes on. So you have trends. So you kind of hook back to some of those early pieces. So that's my four little signs. A lot of stuff with no science, which makes that great. My last little section, I talk about lightning safety, which for here in Ontario is really, I mean, in a lot of places in Canada, it's something we should be talking about more because a lot of people get injured with it. So the goal is not to scare people so that they stay at home. It's just kind of giving them some knowledge around it. So how does, and I'll run through it because it's kind of fun. So we've got clouds, we've got people camping, and what happens is in the clouds is a lot of stuff happens that I have no idea what happens, but here's my 2-minute version, is you have some negative ions at the bottom of the cloud, and you have positive ions at the top. And these negative ions want to ground. So they want to get down to the earth. That's their kind of goal. And so what happens is you have some positive ions that start to put little feeders at the tops of things, and they start to go up. This happens in a fairly quick progression and anywhere. And these little feeders start to come down from the top, and it's a race. And whatever one makes the connection is where the lightning travels through. Okay, that's the kind of quick version. And this is part of the reason why lightning is so unpredictable and doesn't always hit the tallest thing. It's a bunch of little feeders come up from one side, feeders come down from the other, and whatever one actually makes the connection is you know, what ends up happening. Yeah, there we go. So I try to instill with it. It's just kind of a little bit about what happens, but really it's a message about weather or lightning is super unpredictable and you need to really take cautions for it. So my other little piece that I talk about with people, we'll go through it quick, is in this slide, where are, you know, where are the worst places that you could be? So people yell out a bunch of stuff. You know, here's your extremely dangerous spots, obviously tops at points, these guys out in a canoe, that type of thing. So then where are your least objectionable alternatives? And so here's some other spots that are, they're better, but they're still not great. In amongst a tree, it's not great. In a gully, mainly because water flows through the gully and lightning travels through water. There's a bunch of things like that. And then the last one is, where's the safest place to be? And it's basically like in a car or in a house. And so it kind of gets the point across around that type of thing. That there's not a lot of places that you can go in a thunderstorm that's super safe outside of just going indoors, but there's better places to go. And then the last thing I leave with people is the industry standard, which we should all be following, which is the 30-30 rule. And it's really simple for people to understand. So the lightning flash and you hear thunder, if it's within 30 seconds, you need to get off the water, okay? You need to be thinking about getting indoors because the storm is only 10 kilometers away. And so if it's longer than that, like 45 seconds, you know, it's a judgment call, but under 30, that's the industry standard. And you guys as leaders, you should be getting off the water. And then you're off the water for 30 minutes after the last thunderstorm. And which is the slowest 30 minutes of your life. I guarantee it when you have 10, well, you guys have experienced probably, you have 10 people staring at you, trying to figure out what to do. And so someone just starts the clock and every time it thunders, you reset the clock. And the reason why for you guys is that there's this idea in our head that the storm's coming, here comes the danger. Lightning's shooting out all over the place and zapping everybody. But as soon as the storm is gone, like 4 minutes later, you're like, sun's out, let's go. Well, the reality is lightning doesn't always just shoot ahead of the storm. They can shoot behind you. So you need to get that storm away because it can change direction or it can still shoot lightning for it. So 33. So within 30 seconds, you're off the water and then you're off for 30 minutes. And then my last piece around this is any storm within 15 kilometers of you, you could get hit by lightning. It's rare at that stage, but the type of lightning that shoots that far ahead will guarantee to kill you. I wouldn't, you know, use that word. I don't often use the K word for sure, but for you guys. So at about 45 seconds is about 15 kilometers away. So that's quite a great distance, especially if you're somewhere where you can see storms far away. Georgian Bay, we can see them from really far away, out in the prairies for sure. So you can see these storms coming. So you just kind of need to be really aware of what's happening out there. So yeah, the danger zone is about 15 kilometers, and it's where it's bad enough that, you know, you get that, you might have heard that phrase out of a clear blue sky. Well, it comes from something. So just because it's sunny above you, the storm could be far enough away. Lightning comes out of the top. This lightning out of the top of it is, they call it positive lightning, I think. And it's about twice as dangerous as lightning under the negative, under the bottom. So, but enough of that. So I talk a little bit about the concept. The big thing for these, I stress on people, is like, when the thunder roars, you need to go indoors. You know, that's the key message for it. And then we just go from there.